Okay, so that's a pretty basic idea of how branching and data structures and data handling can be useful for geometry. Now I'll just run through a simple geometry example of, again, when paying attention to your data structures will help you in actually creating and handling geometry. So I'm just going to hide this. So now what I want to do is create a surface from a series of splines that I'll define in Rhino, and I'll show you how managing your data structure can help you in doing that. So now what I want to do is I want to create a series of curves to define my parametric surface. For that, I'm going to go into the front view and just start sketching out my curves. I'm going to use just 4 control points for each curve. So there's my first curve. I'm just going to build these sort of on top of each other for now. Alright, so there's my 3 curves. I'll go back to perspective so I can take a look, and then I'll just move them away from each other some arbitrary distance. Alright, so here are the curves I will use to define my surface. The first thing I'll do is bring in these curves into Grasshopper, and for that I'm going to create a simple geometry node. So just type in geo, create this node, and then I'm going to set multiple geometries and pick these splines in order. And in this case it's important the order you pick, because this is actually the sequence that are going to be stored in your node, which again will come in handy later when we start working with those geometries. So once I have those picked in order, I'll hit enter for done, and now these curves are referenced as a list of 3 curves in my geometry node. So the first thing I want to do is I want to create a series of lines interconnecting moments along those curves. So I want to kind of create the members running in the opposite direction. So for that, I will first divide up the curves into a series of points. So to do that, I can use the divide curve command. It's also in your curve tab under division here, divide curve. And into divide curve, I'll input my curves, and then for the number, it's a parameter that tells you how many divisions you want. And I can start with 10, or maybe I'll just create a slider so I can control that. Okay, so once we have that, we have our curves divided. So here again, we're passing a series of 3 curves, and we're dividing them each by 15. And if we go to our data set, you can see what's happened is it's actually created a complex branching data set where each original curve, I'll just bring this down to 10 so we can see this. Basically each original curve is contained within one branch, and then all the points that were created through that division are within that branch. So you can see how now the structure has stored some intelligence about what our geometry is doing. This can be sort of confusing at first, but it can also come in really useful when we start manipulating this geometry. You can think of the alternative if it didn't have the structure, and basically if we flatten everything, you see it gives us this straight list of points, but it doesn't have any intelligence about where those points came from. Okay, so we'll just get rid of the flatten here. So that's our data, and now we want to interconnect these points across the lines with new polylines. So I'm going to create a polyline component, and polyline will just take in a series of vertices and connect them together with a polyline. So if we just by default bring in these points into the vertex input, you can see it doesn't look like anything has been done, but if we hide our original curves and we go into Rhino, select them and hide them, you can see that the polyline has actually recreated our curves. And the reason it's done this again is because of the data structure. You see that when it inputs this, it'll do this operation on each branch separately. So what polyline is actually doing is going to each branch and saying, okay, I'm going to take all these vertices and interconnect them. Then I'm going to take all these vertices and interconnect them. And then take all these vertices and interconnect them. Alright, so that might be what we want, but in this case it's not, right? We want to actually take the first value here and the first value here, and the first value here, and create a polyline, and so on and so forth. So to do that, we basically have to flip the structure of our tree. Instead of having 3 branches with 10 points each, we want 10 branches with 3 points each. And to do that, this is actually quite a common thing to do. There's a special component in Grasshopper in the trees called flip matrix, and you can read about what it does if you hover over it. If you have a matrix-like data tree, so this means like one series of branches with some number of items in each branch, you can flip the way that's organized. So if we plug in our point data here, and we visualize that, you can see now it's given us what we want. We basically have a series of 10 branches with 3 points in each branch, and these 3 points represent the points along each curve at that position. So this is the first point from all 3 splines, the second point, so on and so forth. So now if we plug that into our polyline, you can see we've generated what we want. So this generates our interconnected polylines. And if we unhide our original geometry, now we have our kind of bi-directional definition of our surface.